Good morning, happy Friday. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I will respond as soon as I can. All right, I didn't get any emails overnight or this morning from students about questions, but while you're here, do either of you have any questions?
No.
Not really.
Okay, well then I'm going to press onward. And so this is still section 10.4, the rest of it. And then of course, over the weekend, also your chapter review assignment. Monday we'll review for a test on Tuesday. What we're going to look at in the second part of this section is another method of finding the axis of symmetry and the vertex and graphing parabolas. And then we're going to look at some application problems that will also deal with parts of the parabolas. Okay, so yesterday we looked at equations in the form y equals a times x minus h squared plus k. And we said that the axis of symmetry is at x equals h. The vertex is at hk. If a is greater than 0, the parabola opens up, and this is a minimum. If a is less than 0, the parabola opens down, and the vertex is a maximum. Okay, now, today we're going to look at second degree or quadratic equations in the form y equals ax squared plus bx plus c, which is the form we typically put it in if we're going to plug numbers into the quadratic formula, or even going way back to chapter 6 when we're going to solve an equation by factoring. All right, when it's in this form, this new form, the axis of symmetry is at x equals negative b over 2a. Again, using these numbers. The vertex is at negative b over 2a. Recall that the number that's the axis of symmetry, the x value, is also the x value of the vertex. And then the y value we would get by taking this x value, plugging it back into the function, so the y value would be f of negative b over 2a. And that looks kind of complicated, but all we're doing is saying, use this to find the x value, and that's also your axis of symmetry. Plug that x value in and get the corresponding y value. Now, all the information to do with a is still the same, because an equation in this form and this form, a is the same number. Okay. Any questions about that information yet? All right, we're going to apply it to some problems. Let's take the following question. Let's see here. We've got f of x equals x squared plus 2x minus 5. And it says to find the vertex of each function. What I'm going to do, I'm going to go ahead and find the axis of symmetry and the vertex. I'm also going to talk about whether it opens up or down. So I'm going to do more than the instructions, which you don't see anyway. Okay, this is in the form y equals ax squared plus bx plus c. So a is 1 and b is 2. So x equals negative b over 2a would be negative 2 over 2 times 1, which is negative 2 over 2, which is negative 1. So the axis of symmetry is at x equals negative 1. So if we were graphing this thing freehand, Over here at x equals -1, we'd have a dotted line representing the axis of symmetry about which the graph is symmetric. Okay, now to find the vertex, we're going to take the x value, -1, and we're going to plug it in and find f of -1, which would be 1 minus 2 minus 5, which is -6. So the vertex is at -1, comma, -6. So here's the axis of symmetry. Here's the vertex. Any questions about that? Since a is 1, a is greater than 0, this parabola opens upwards. Let's see. So basically, we've got the vertex down there at -1, -6, and this thing's going to open in an upward direction. Any questions about that information? And again, it wasn't asking us to graph it. We'll get to that here. Okay, let's take a look at another example. F of x equals -x squared plus 4x minus 5. This is also in the form y equals ax squared plus bx plus c. A is -1 and b is 4. So x equals -b over 2a would be -4 over 2 times -1, which is -4 over -2, which is 2. So the axis of symmetry is at x equals 2. So again, if we were doing a freehand graph, we would have the axis of symmetry, vertical line at x equals 2. F of 2 is -2 squared plus 4 times 2 minus 5, which is -4 plus 8 minus 5, which is -1. So the vertex is at 2, -1. So here's the axis of symmetry. The vertex is at, let's see, 2, -1. So right there, 2, -1. There's your vertex. Oh, A is -1, so this thing opens downward. Okay? Any questions about that?
No.
All right. How do you find an X-intercept? Set y equal to 0. So complete ordered pairs in that form, right? That's true of linear equations. It's true of quadratic or secondary equations. How do you find a y-intercept? Set x equal to 0. So to find x and y-intercepts of the graphs of these parabolas, to find x-intercepts, we'll set y equal to 0. To find y-intercepts, we'll set x equal to 0. All right, so let's take a look at some examples. Let's say we've got the function f of x equals x squared minus 2x minus 35. So to find x-intercepts, I'm going to set y equal to 0. If I set y equal to 0, I get that. Isn't that the form we use to solve an equation using the quadratic formula?
Yes.
So in fact, good. So in fact, when we're finding the solutions to setting the equation equal to 0, those solutions actually represent x-intercepts on the graph of the parabola. Okay, so let's solve this thing. We'll use the quadratic formula. A equals 1, B equals -2, C equals -35. X equals -b plus or minus the square root of b squared minus 4a C all over 2a. X equals 2 plus or minus the square root of 4 plus, let's see, 4 times 1 is 4 times 35 would be 140, and negative times negative again is positive, so 140. Oops, 140. Sorry, I'm getting ahead of myself there, all over 2. So X equals 2 plus or minus 4 plus 140, there's the 144 all over 2. So X equals 2 plus or minus 12 all over 2, because the square root of 144 is 12. So then we've got X equals 2 plus 12 over 2, which is 14 over 2, which is 7. And X equals 2 minus 12 over 2, which is negative 10 over 2, which is negative 5. So my two X-intercepts are 7, 0 and negative 5, 0. Any questions about that?
No.
All right. To find the Y-intercept, you set X equal to 0. Well, if we have an equation in the form Y equals AX squared plus BX plus C, and we find F of 0, this goes to 0, this goes to 0, and what's left is C, the constant. So the Y-intercept would be at 0, negative 35. So to find X-intercepts, we set Y equal to 0, solve the equation using the quadratic formula. To find Y-intercepts, we set X equal to 0, and it's going to actually be the constant out at the end, because the AX squared and the BX are both going to become 0. All right. Now, let's take a look at a problem where we're going to do the whole thing. We're going to find the axis of symmetry, the vertex, the X-intercepts, the Y-intercepts, and we're going to graph it. Okay? Now, what I want to do, actually, I'm going to close this up, which gets rid of all that, open it back up, because I want to use the screen that's right below the graphing grid. It'll just make it easier for me. And it's all about making it easier for me, right? Okay. F of X equals 2x squared minus 8x plus 6. All right. First of all, we're going to find the axis of symmetry. So we're going to use X equals negative b over 2a. Let's see, a is 2, b is negative 8, and c is 6. So that would be negative times negative 8 over 2 times 2, which is 8 over 4, which is 2. So the axis of symmetry is at X equals 2. And I want to remind you again, when you plug it in on WebAssign and it says the axis of symmetry, you've got to write an equation, X equals 2. If you just put 2 in there, it's going to mark it wrong. I think I get that question asked more than anything from students, or they get it wrong. Okay. So now to find the vertex, I'm going to find F of 2 to find the corresponding Y value, which is 2 times 2 squared minus 8 times 2 plus 6. I wrote minus, I said minus, and then I wrote plus. The mouth and the brain haven't made a connection. I think that's correct. So I've got 2 times 4 minus 16 plus 6, 8 minus 16 plus 6, which would be what, negative 2? So the vertex is at 2, negative 2. All right. Any questions about that? So now we're going to find X and Y-intercepts. Okay. So to find X-intercepts, we're going to set Y equal to 0, which means we would have 0 equals 2x squared minus 8x plus 6. Okay. Now, Looking at the right side of this equation, I could divide everybody by 2 and reduce it down to 0 equals x squared minus 4x plus 3. Now, the Math 93 students don't learn how to factor, so they have to use the quadratic formula. You did learn how to factor, so if this factors using the quadratic formula, you could certainly do that if it factors easily, rather than having to go through and use the quadratic formula. I'm going to do that. Let's see what happens. Is that correct? Does it factor into that? So then we'd get x is 3 and x is 1. So the x-intercepts would be at 3, 0, 1, 0. Now, why did I do it that way? Just to save time. If you want me to, I'll go back and use the quadratic formula. Do you want me to do that? I'm happy to. Nope. Okay. All right. To find the y-intercept, we're going to set x equal to 0. Well, if x is 0, what do we have left? 6. So I now have the axis of symmetry, the vertex, the x-intercepts, and the y-intercept. Any questions about any of those points? All right. So let's graph this thing. Let's see. The axis of symmetry is at x equals 2. So that would be right here. So the AOS x equals 2. Okay. The vertex is at 2, -2. So that's right there. Oh, does this thing open up or down?
Up.
How do you know?
Because the a is greater than 0.
Correct. Good answer. Okay, let's see. We've got x-intercepts at 3, 0, and 1, 0. And a y-intercept at 0, 6. Now, that dotted line is the axis of symmetry. So in fact, I could take this point, and using the axis of symmetry, I could also get that point because it's the same distance, but on the other side. You see that? Okay. So
Yeah.
now, let's see if I can find a, I'm trying to use my curved thing here. Let's see. That, and then that. And this, of course, extends on beyond it. So there's a graph of the parabola. It has an axis of symmetry at x equals 2. It has a vertex at 2, -2. It has a y-intercept at 0, 6, and x-intercepts at 1, 0, and 3, 0. All right. Also, it has a minimum at y equals -2. So the y value of the vertex would be the minimum value. Any questions about the graph? Now, again, in WebAssign, if we were graphing this, what you would do was you would plot this point, the vertex first, and then you would plot any second point that's on the graph, but you got to do the vertex first. Okay. Now, I believe that in WebAssign, it will ask you things like, what are the x-intercepts? What are the y-intercepts? What's the axis of symmetry? But when you go to graph it, I don't think it specifically asks you to graph x or y-intercepts, but you can certainly use those points to graph. Again, the vertex first, and then a second point. All right. Do you need more examples of this, or are you okay with it?
I'm okay with it.
Giovanni?
I'm okay with it.
Okay, then I'm going to move on to the application problems. Now, these application problems that are with this section tend to ask questions along the lines of, what is the maximum area? or what is the minimum cost? They have to do with maximums and minimums. And recall that I said that when you have a parabola opening upward, the vertex at the bottom is the minimum. When you have a parabola opening downward, the vertex at the top is the maximum. So the answers to the questions are typically going to be within the vertex of the parabola, or they also might be X-intercepts, as we may see here. Okay, so here's the first problem. I'm going to read it to you, and then we'll go back and look at it again. It says the cost C in dollars of operating a certain concrete cutting machine is related to the number of minutes in the machinery is run by the function C of n equals 2.25 n squared minus 66 n plus 655. For what number of minutes is the cost of running the machine a minimum? And what is the minimum cost? Okay, so let's look at our equation. Can you see it's a second degree equation? So the graph is a parabola. A is positive, so it's going to open downward. So our parabola, if we were going to graph it, would look roughly like that, right? Okay, now, oops, I did that incorrectly. Sorry, the brain and the mouth disconnected there. It would open like that because A is positive, which means down here the vertex is going to be the minimum. Now, let me read it again. The cost C in dollars, so C represents cost, of operating a certain concrete cutting machine is related to the number of minutes in. So N is the number of minutes, C is the cost. Think about this also. If we graph this thing, this is N and this is C. This is the number of minutes and this is the cost. Okay. For what number of minutes is the cost of running the machine a minimum? Well, where is the minimum C value? It's at the vertex, that low point. So what I need to do is I need to find the input and the output of the vertex. Now, instead of calling it the X and Y, I called it input and output because we're using N and C as our variables, but it's the same thing. I'm going to go back to just X and Y for the moment here. Let's see. X equals negative B over 2A, and that would be negative times negative 66 over 2 times 2.2, which would be 66 over 4.4. Okay, and 66 divided by 4.4 is 15. So the vertex is at 15 comma what, C of 15? So let's find C of 15. 2.2 times 15 squared minus 66 times 15 plus 655. Calculator time. Helps if you turn the calculator on. 2.2 times 15 squared minus 66 times 15 plus 655. And I come up with 160. So C of 15 equals 160. That's money. So the vertex is at 15, 160. Okay. But the input is minutes. So 15 minutes. The output is cost in dollars. So $160 is the minimum cost. So the questions, it said, first of all, what is the number of minutes, or for what number of minutes is the cost of running the machine minimum? So that would be 15 minutes. And then what is that minimum cost? $160. Are you okay with this?
Yes.
Okay. Now, just something to consider. Let's say that you get a function and it's opening down, but it's asking for minimums. Something's wrong. or you get a function that opens up and it's asking for maximums, there's something wrong there, okay? Because if it opens up, it should be asking for minimums, opens down, it should be asking for maximums. All right? Okay, let's take a look at, let's see here. New problem, it says fireworks. The fireworks shell, or a fireworks shell, is shot straight up with an initial velocity of 120 feet per second. Its height, s, in feet after t seconds is approximated by the equation s equals 120t minus 16t squared. If the shell is designed to explode when it reaches its maximum height, how long after being fired and at what height will the fireworks appear in the sky? Okay, so t is time in seconds. S is height in feet. Okay, first thing I'm going to do, I'm going to take this function and I'm going to rewrite it, putting it in descending powers of the variable form. Okay. Okay. Now, that would be a parabola opening downward, right? Because A is negative. This would be the t-axis. This would be the s-axis. They want to know at what time does it reach its maximum height, and what is that maximum height? So the vertex right there, the t value would be the time it took to reach the s value, the highest height. So again, we need to find the vertex, okay? X equals negative b over 2a, and technically I'm looking for t, not x, but that's going to be negative 120 over 2 times negative 16, which is negative 120 over negative 32. Let's see, negative divided by negative is positive, and 120 divided by 32 is 3.75. So t is 3.75 seconds, okay? That's the input value of the vertex. That's the time it takes for that fireworks to reach the maximum height. Now, how do we find that maximum height? We find s of 375. So s equals 1, let's see, I should be using this one. It doesn't really matter. They're both going to give me the same result, but so that would be what? Negative 16, 3.75 squared plus 120 times 3.75. And again, calculator time, negative 16 times 3.75 squared plus 120 times 3.75, and I get 225. So the vertex would be at 3.75 comma 225, and 225 would be feet. So this is the maximum height, and this is the time it takes to reach the maximum height. So the questions, again, it said, how long after being fired and at what height will the fireworks appear in the sky? How long after being fired? 3.75 seconds. And what height? 225 feet. You okay with that?
Yes.
All right. Next example. This says projectiles. A ball is thrown straight upward from the top of a building with an initial velocity of 32 feet per second. the equation S equals negative 16t squared plus 32t plus 48 gives the height S of the ball in feet, t seconds after it's thrown. So S again is height, and this is in feet, and t is time in seconds. Okay. It says find the maximum height reached by the ball. Oh, this has an a value that's negative, so the parabola is going to open downward, so it's going to have a maximum. So the maximum height, that would be the S value of the vertex, the second coordinate, and the time it takes for the ball to hit the ground. That's not in the vertex. Let me ask you this. How high is a ball when it hits the ground? Anybody? Wouldn't it be 0? Well, something to think about. All right, let's draw a picture of this situation. So the ball is thrown, it reaches a maximum height, it comes down and hits the ground. So this would be the vertex, TS. This would be what? The X-intercept, which would be T, 0 height. Isn't something on the ground 0 height above the ground? Are you both still there?
Yes.
Okay, sorry. Are you understanding that?
Yeah.
Okay, sorry. When I don't hear anything, I'm not sure if I should go on or wait or whatever. Okay, so let me ask you this. Right here, at the beginning of the problem, before the ball is thrown, how much time has elapsed concerning the flight of the ball? So I'm getting ready to throw the ball. I haven't thrown it yet. How much time has the ball spent going through the air?
0.
Good. So let me ask you this. What's the height of the building? Right here. When the problem starts, no time has elapsed. So the time is 0. What's the height of the building? "48 feet. Think about it. If time is 0, what's the height? 48 feet. So this distance right here is 48 feet. Is that making sense?
Yeah.
Okay. Now, that wasn't a question asked. That was me asking because I just want to point things out to you. All right. Now, let's find the vertex. So x equals negative b over 2a, which is negative 32 over 2 times negative 16, which is negative 32 over negative 32, which is 1. So the time elapsed is 1 second to reach that maximum height. Let's find that maximum height. So we're going to put 1 in for time. Which is going to be 64. So maximum height, 64 feet. Now, that occurred 1 second after the ball was thrown, but they didn't ask how long it took. They just said, what was the maximum height? Okay. And then it says, when did the ball hit the ground? Okay. So again, what is the height of the ball when it hits the ground? It's 0. So we're going to take this formula and we're going to put 0 in the place of S. So at what time was S equal to 0? Oh, but now we've got it in a form where we could either factor it or use the quadratic formula. Okay, I'm actually going to reduce it down first. I could factor out a -16 and then divide both sides by -16. So I could say 0 equals t squared minus 2t minus 3. Do you want me to solve that by factoring, because it factors fairly easily, or using the quadratic formula?
We can factor it.
Okay. Sorry I'm making you guys talk so much today. Okay, so this is going to be what? -3 and +1. So t equals 3, t equals -1. Now, time can't be negative, regardless of what they tell you on Star Trek or science fiction movies. So that one's out. So t equals 3. So this would be at 3, 0. So when does it hit the ground? After 3 seconds. Okay, maximum height is there. Time after it hits the ground after 3 seconds. Okay, now I want to talk about this value that I threw out, t equals -1. The problem starts right here. But if we continue to draw the parabola, this other intercept would be -1, 0. But so it fits the graph, it fits the equation, but it doesn't fit the actual problem because it has to start when time is 0, okay, which is right there. Any questions before we go on to another example?
No.
All righty, here we go. Suppose you are a police patrol officer and you have a 300-foot long roll of yellow do not cross tape, or do not cross barricade tape, to seal off an automobile accident as shown in the illustration. Okay, you can't see the illustration obviously, but what they've done is they've formed a rectangle with this yellow tape. Okay, and then inside here there's some cars and a big mess. Okay, that's my big mess. What dimensions should you use to seal off the maximum rectangular area around the collision? And what is the maximum area? Now, they tell us we have 300 feet of tape, and they want the dimensions and the maximum area that we could create with this rectangle. Okay? Now, since this is a rectangle and we have 300 feet of tape, the entire perimeter would be 300 feet. What I want to do is I want to cut this in half, and I want to say, okay, if the whole thing is 300 feet, then how much would just half of it be? That would be what, 150 feet? You okay with that? Now, let's say that this represents two sides of the rectangle. This piece here and this piece here, okay? If that totals 150 feet, if I call this piece X, so this little piece here, okay? If this is X, if the whole thing is 150 and the little piece is X, what's the big piece? Well, this is 150, take away X. So 150 minus X. Does that make sense? Are we okay with that? I'll take that as a yes. All right. We're supposed to maximize the area. Well, area is length times width. Let's write a of x. Let's write it as a function, and that's going to be 150 minus x times x. So the area is the length times the width. So then simplifying the right-hand side, I get 150x minus x squared. Putting it in descending powers, I get negative x squared plus 150x. So there's my function, my equation that describes the area in terms of x, which is one of the dimensions. Okay, now, again, what did it say to do? It said, where is it here? What dimensions should you use to seal off the maximum rectangular area? And what is the maximum area? So we need to find x so that we can get x and 150 minus x and then the maximum area. Well, again, this equation, it's a parabola. A is negative, little a, so it opens downward. This is x. This is a of x. So this is x comma a of x, the vertex. Okay. So to find x, I need the input value of the vertex. So x equals negative b over 2a. B is 150 and a is negative 1. So I get negative 150 over negative 2, which is 75. So that means x equals 75 feet. 150 minus 75 would also be 75 feet. So the dimensions are 75 feet by 75 feet. So in fact, this rectangle is a square. Okay. Now, we're supposed to find the maximum area. There's actually two different ways I could do it. Since I now know the dimensions are 75 by 75, I could just take 75 times 75 and get 5,625 square feet. Or I could do it the other way, and I could find a of 75, plugging the x value into the function will give me the vertex, or excuse me, the y value, the vertex. So that's going to be what? Negative 75 squared plus 150 times 75. And when you do it that way, you get 5,625. So this is 5,625. So the vertex of that graph would be 75 comma 5,625. 75 is x, so the dimensions are x, 75 by 150 minus x, 75. So that's a square. The maximum area is 5,625 square feet. Any questions about this problem? All right, I got one more to go through with you. Let's see here. My lovely artwork here. Okay, now, that's what it says. Ranching, an illustration, or see the illustration. A farmer wants to fence in 3 sides of a rectangular field with 1,000 feet of fence. The other side of the rectangle will be a river. If the enclosed area is to be maximum, find the dimensions of the field. Okay, so the farmer wants to maximize the area because the area has grass in it where the cows can graze. But I just want to point out that the farmer is an idiot because the water will not keep the cows in. They will wander out into the creek and who knows what, okay? They won't just necessarily, you know, stay out of the water. But I lived on a farm, so that's why I know all these things, right? Okay. Point is, though, we're going to build 3 sides of a rectangle instead of the whole thing. Now, if this is a rectangle, wouldn't you agree that those two sides are going to be equal, whatever they are? So we could call them both the same letter. We'll call them X. Now, let's say I have here. So these are the three sides up against the river, okay? Now, the total length of those three sides is 1,000 feet. We've established that the two pieces that are the same are both X. So if this whole thing, let me put it back together here. If this whole thing is 1,000, and I take away an X, and I take away an X, I've taken away 2X. So the remaining piece would be 1,000 minus 2X. So this is different from the last problem where we had all four sides that we built. Okay? Now, using area equals length times width, A of X equals 1,000 minus 2X times X, length times width. A of X equals 1,000X minus 2X squared. A of X equals negative 2X squared plus 1,000X, putting it in descending powers. Okay. Now, graphically, this is a parabola opening downwards. This is X. This is A of X. This is the X-axis representing this distance. This is the A of X axis representing the area. I want to maximize the area. So I need to find the X and Y value of the vertex. The Y value would be the maximum area. The X value will be this dimension, which will allow me to find the other dimensions. So X equals negative B over 2A is negative 1,000 over 2 times negative 2, which is negative 1,000 over negative 4, which is 250. So this is 250 feet. This is 250 feet. 1,000 minus 2 times 250, 1,000 minus 500. This would be 500 feet. So the dimensions are 250 feet by 500 feet. Now, to find the maximum area, again, we could do two different things. So maximum area, it would be 250 times 500, which would be 125,000 square feet. Or we could find A of 250 and plug it in here, and we would also get 125,000 square feet. I just want to point out one last thing. So in WebAssign, boy, the voice is doing great today, huh? In WebAssign, on this problem where you've got the rectangle around the accident, sometimes it'll ask for the shortest distance or the minimum distance or the maximum distance, the shorter, the longer. But in this case, if the dimensions are the same, you would just put them in for whichever, okay? I know students kind of got confused about that before, so just wanted to keep that in mind. All right, that's it for today. I will be back at 1:15. I'm going to stop the recording.